Okay, so today we're continuing and ending our look at end behavior models as far as lessons. And we're also looking at how investigating reciprocals can help us answer some of our limit problems. So in this example, this is on end behavior model 1. And if you remember, on a previous lesson, I had said that sometimes right end behavior model is different from the left end behavior model. So g of x is a right hand behavior model and h of x is the left end behavior model. So now we have to kind of prove both. Here we go. So let's do the right end behavior model. That is where our limit of f of x divided by g of x, okay. Oh, g of x got cut off. Let me help you out there. It's just x. As x approaches positive infinity. So we're going to divide both terms by x. And this one cannot be simplified. So we already know the limit of 1 as x approaches infinity would be 1. Hopefully the limit of e to the negative x over x is 0. And let's check that out before we do say it's 1. So let me get a picture here. Okay, so I put it into the calculator so we can figure this out graphically. It does get really close to the x-axis here. And if you look at it numerically, it does become 0. So this does work out. We do get 1. So now let's do our left end behavior model. Okay, so for doing the left end behavior model, it's the limit of f of x divided by h of x. And as x approaches negative infinity. So here we have the limit of x over e to negative x and the limit of 1. Okay, I didn't use the property there to kind of split it. You do know that this is the case. All right, now we know the limit of 1 is going to be 1 here. Hopefully that this is 0, so let's check that out because we do want an answer of 1. Okay, so I kind of like this graph. As x approaches negative infinity, it gets really close to the x-axis where y is equal to 0. You can check that numerically. So this is right. The g of x is the right end behavior model and h of x is the left end behavior model. All right, so good luck with your other problems with end behavior models, and let's actually go to some other problems where we investigate reciprocals. Okay, so what this is saying is that we have f of x, or we have f of 1 over x. And sometimes we can investigate or analyze the graph of f of x as x approaches either positive infinity or negative infinity by investigating the graph of f of 1 over x. So perhaps f of x is unclear or we're not sure of what it is, but we can definitely see what's going on of f of x, this is a tongue twister, of 1 over x as x approaches 0 because it's closest to the origin. We can kind of zoom in at the origin and really understand it. And sometimes it's vice versa. Let's say we have the f of 1 over x, 1 over a common function. And we need to find its limit. Well, maybe we can find it by using f of x. So just giving you a heads up that sometimes it's vice versa. So for example, if we look at the graph of y equals x, and I'm sketching its graph here so we can kind of see what's going on. And we get a feel for what we're saying. And y equals 1 over x. So it's 1 over our common function, but it happens to be a common function, so we should know its graph. Okay. All right. Let me write this out so we can see it. Okay. As x approaches positive or negative infinity, okay, we can see how, let me point that out. X approaches positive infinity, our answer is infinity, okay? So if we look at as x approaches 0 from the right, it's positive infinity. Now let me do a different color here. Now, as x is approaching negative infinity for y equals x, you can see how it keeps going down, so that's negative infinity. So the limit of 1 over x as x approaches 0 from the left is negative infinity. So they tie in together. And it's also like the vice versa. So if you have to do the opposite, if let's say we're looking at as x approaches 0 from the right, we also know the answer over here, okay? If we're looking at the limit as x approaches 0 from the left, we know the answer here, okay? So you can also do this with y equals x plus 1 and y equals 1 over x plus 1. And in our example here, we can see that it's the sine of 1 over x, okay? And we're going to use the limit of sine of x to figure out that first limit, okay? I should have described it as x approaches infinity, but we will get to that. All right, so here we go. Our example. So we want to know the limit of sine of 1 over x, which I'm not sure of what its graph looks like as x approaches infinity. But I know the graph of sine of x. So if it's x approaches infinity, I'm going to look at as x approaches 0 from the right as I take its limit. So if we're to look at this common function of ours, okay, and we plot some points. Okay, so this is basically sine of x from negative pi over 2 to pi over 2. We can see that as x approaches 0 from the right, its answer is 0. So you know what? This answer is also 0. Ta-da, we're done. Okay, so we can figure one out without a graphing calculator if we know what the other graph looks like. So it's extremely helpful when you have like non-calculator sections of your exam. Good luck.